Hi. I'm live, right? Yes. So today I will try to solve the questions of two contests, weekly contest and bi-weekly contest. This is bi-weekly. Let me just open both side by side. Okay, cool. And let me just update this. So let me just first count how many we have easy problems. We have one easy here. We have one two easy, four medium, two hard. Cool. Two easy, four medium, and two hard. Keep, so we'll keep track of this thing. And trying first lit code. Easy. We'll start with easy. Okay. Cool. Audible, right? Oh, wait a minute. I guess my voice is not louder enough.
Yeah, I hope this is fine now. Let me just
Cool.
clear
And let me just update this.
two line. Let me just
Cool.
clear
And let me just update
cool
this.
two line. Let me
Cool.
just wait for a few minutes so others can join. Then I
And
can
let me
start.
just update
Cool
this.
two line. Let me
Cool.
just wait for a few minutes so others can join. Then I
And
can
let me
start.
just update
Cool
this.
cool. Should I begin? I guess now. What's the time? 6:45. Yeah, it's fine. Let me begin. Wait. Let me quickly open the live chat also. Okay. Now we can start. Okay, let me just start quickly. So I will take first question from bi-weekly, then one question from weekly. Likewise, we'll follow one weekly, one bi-weekly, one weekly. So we have two easy question today, four medium question, and two hard question. Okay, let's go. So the first is the question from bi-weekly is rearrange string to avoid character pair. Okay. So question is you are given a string S and two distinct lowercase English letter X and Y. Okay. Rearrange the character of S to construct a new string T such that T is a permutation of S. Okay. Every occurrence of Y appear before every occurrence of X in T. Return any valid string T. Okay. So the point is they want every occurrence of Y should appear before every occurrence of X. So they want all the Y character. Let's say all the Y character should appear before X. Right? This is what they want. And we doesn't like we don't care anything else other than these two characters. The simplest way will print all the Y character, print all the X character, and then print rest of the characters. Right? This is the simplest solution. So count, let's say count Y, Or what we can do, there's I don't want to make it complicated, but we can use a custom sort here also. But let me first tactic that I will discuss will print all the y character, then all the x character, then remaining characters. Okay, this is how we can do. So for that, let me just count how many x character are there and how many y character are there. Or we can simply do like this. If you don't want to go in details, like just bring answer like this, then write for, three for loop I over s. If I is equal to y, then answer plus is equal to I. So all the y we have appended in our answer. Similarly, all the x we have appended in our answer. Similarly, if I is not equal to y and I is not equal to x, and we have appended, then we'll return our answer. This is the simplest solution. See, let me just submit, and we got accepted, right? There's See, what we did is read the question to find out the pattern, like the easiest way of how we can solve this question. And this is order of n, right? If some see, there's that lots of this is an easy problem there. You don't need to apply your brain. You just need to think like how you can submit as fast as possible if you are in a contest. Okay. So we have done with the first easy question. Let me quickly update the question count here. To solve one, and let me just quickly bring back. Yeah, this is easy, Milan. Trying second is the question. I have one more tactic to solve this question also. What we can do is we use custom comparator, and in custom comparator, we'll tell the comparator give the priority, give the y as the lowest priority, x as the I can, like for example, what I can do is, let me just quickly summarize. If you don't want to write three for loops, so what you can do is assign x to 0, assign y to 1, and assign rest of the character to 2. Then sort the string. So may what y to 0 and x to 1 and rest character has 2. Then what you can do is then sort all the character, and definitely all the zeros will come first, all the 1 will come after, and all the 2's will come at the end. So this will solve the what the question asks, right? All the y character come first, all the x character, like this. So for that, what we can do is sort s dot begin comma s dot end, and here you have to write your custom comparator. And I forgot the syntax, something like this, right? Uh, char, let's say to A, char B. What the syntax of custom comparator is like this only. Let me just quickly compile. If char B, what's the syntax of custom comparator? Custom comparator in C++. Just want to know the syntax. This is what, yeah, we are have. So I wrote, this is the correct syntax. Okay, this is the correct syntax. So what we'll do here is, we'll give the priority. If, how can we give priority? Return A is equal to X, A is equal to Y, or B is equal to Y, or A is equal to X, or A is equal to B is equal to X. X. I don't think so this will work, but we have to assign like this, then it will work. But here we need to number what we can see. We already have a solution. This is the easiest solution. But in case if you see, we are using every language has some specification, right? So C++ has a specification in a sort, like you can use a custom sort, and so you don't need to write three for loop. This function in itself serves the purpose. So the point is, what you can is you can modify this like this. Sort, what you can use string temp is equal to null, and what you can do auto x over like auto I over s. If you find I is equal to y, then temp plus is equal to 0. Else if I is equal to x, then temp plus is equal to 1. Then what you can do here is else temp plus is equal to 2, right? Now you can sort this temp, right? Now what you can use, now you can bring your answer. Now you can build your answer. String answer is equal to now. For auto and person I over temp. Now what you can do is if I is equal to 0, then you can do answer plus is equal to y. Else if I is equal to 1, then you can do answer plus is equal to x. Else, but here you fucked up, right? You don't know what 2 means. What did you? Why I'm the only one who does in Java? No, crazy insan, no. It's not like this. C++, why everyone choose C++? Because C++ is a fast test, like it has a good runtime. So you don't need to worry about the runtime optimization. You just need to worry about logic building. Rest of the part is done. For example, say if you use Python, so sometimes the recursion, if you write recursion in a Python, it can goes into a 500 millisecond, but the same recursion can bring your runtime to 200 millisecond. So for every language has some specification, right? Python is very good for ML and machine learning because it provides lots of library there. See, I'm not going like I don't want to go in this. My main concern is instead of this, we can write the similar solution using one sort function using comparator, where we have to treat each character like this. We have to I forgot like how we can assign the character value to character in a sort. We'll discuss that later. For now, we'll go with this only. Okay? So I don't want to waste much time in this problem. That's why otherwise at the end of stream we can try to code if you want. Trying second, okay? Wait. Okay, the second is the problem. So what is problem is saying even number of knight moves. Okay, so it's a chess problem. The problem is you are given a two integer array, start and end, where each array is a form of x. That means you have given a coordinate of start and end in a form of x and y, 2D coordinate in a 8 cross 8 chessboard. Return true if knight can move from start to target in an even number of move. Otherwise, return false. So we have to say, can knight move from start to end in an even number of moves or not? A valid knight move is, right? Knight can move like this, two and one, two straight and one from left or right. And it's an easy problem. So brute force, of course, works, right? What you can do is you'll find all the possible way from start to end, from start to target, and for all the paths, possible paths, you will check which it does there any path exist which has a even number of moves. If that exists, you will return true, otherwise false. That's the brute force. But can we do in the simplest way or not? Let me just think for a while. Let's say start position is this, end position is this. And does it always possible ki we can reach from task to end? Does No, it's not always possible, right? So firstly, we have to check, does we like do we reach actually reach or not from start to end? So there are few test cases. Let me just quickly summarize. So what we have to first look is we are given a start and end, right? We have start position and end position. Okay, correct. And apart from this, first of all, there are options like first option is can we reach from start position to end position? Then we return true, otherwise we'll return false. Okay. Now, no, still, if we not say here we can say if we can't, if let me first write this, if we can't reach, then we'll definitely say we have to return false here, right? In this case, return false. Second case, we may reach, we may reach end position. Then our second constraint is the number of movies even. Then we have to check does does we have reached in even number of move or not. Moves or not. So these are the possible scenarios, right? And knight can move at a time eight direction. I know, like the brute force, I know, like we can apply brute force, but the code is quite bigger, right? For each point you will explore, and it is under the time constraint. The constraint is too low. See, constraint is too low here, so that doesn't matter here. But I'm thinking, do we can we do a better? We can apply a breadth first search or DFS or BFS from the start to end position, right? And we can check how many moves. Like, does there any path exist with even moves, and will immediately return true if that it's such a path exists. But you know, guys, right? If you guys are aware of BFS, then you'll know the code is quite big, right? And it's an easy problem. So there might some kind of trick exist here, and we can say we can reach. Like we don't need to go for traversal. Does anyone have any idea? Like, do you guys think we are without any traversal, it's mathematically we can convey like we can reach in an even number of move or not? It's not possible, or it's possible. Do you guys? What do you guys think? Let me give a few to just think for a while. Definitely, traversal algorithm serve a purpose, right? But it's an easy problem, so I don't want to go with traversal. And my like, I want to think for a while. I can implement traversal and that can serve a purpose. But just put a pressure on your brain and think, do we actually need traversal in this case or not? It will be fun. Just give a challenge to your brain. Because currently there's one solution in my mind. We can do this like using BFS or DFS. We can solve. We can solve. But the cons is code is big, quite big. Code is bit longer for easy problem. Can we do something better? Does anyone have an idea? I'm open for ideas now. Or otherwise, I can implement this BFS or DFS, whatever you guys can suggest. See, it's a keep in your mind, it's a easy problem, right? Oh, oh, Jana, Jana. Mm, mm, mm. If you guys watching my stream, do like that can bring new viewers also and more viewer, more discussion, and that makes an interest. Let see. Meanwhile, you guys think, let me implement a travel search, right? So what I will do here is, let me quickly write a travel search algorithm. So we need a queue of vector queue, okay? And we pushed our queue dot push start, okay? While queue dot while queue is not empty. See, this is the standard format to write an BFS. I'm writing a BFS here. So I solved lots of problems, a BFS problem. So it's just a pattern. Like my mind quickly remember the pattern how we solve BFS. You you solve this. I just want to check spelling. Q or Q's. It's a Q, right? So what we'll do here is uh, it's a zero base or one base. So in the coordinates are zero base, so we don't need to worry about that. So what we can do here is we take the element and for example say start is this. We have a chessboard here. Okay. We want to I'm not this is not a perfect chessboard just for a demonstration purpose. Let's say this is our end and this is our start. So we have already pushed this point. Now we have to explore this. If horse is here, how many movement, like how many different movement can horse can go from this? It can go like this, right? It can go like this. It can go, horse can go like this, and yeah. So what we'll do here is we push these points in our queue and start exploring from this point. And if horse is here, how many point it can move? It can move like this. It can move like this. It can move like this, and it can move like this. Wait just a minute. Wait. Okay, let me just continue. And from here it can move like this. From here it can move like this. So we again, so using this point we get more points like this. So this is a, I'm not going into depth of how a traverse algorithm look like, but this is the high level how traverse algorithm look like. So see, you actually reach here, right? From this point to this point, to actually reach how many moves you have did to reach from start to end. You perform this one and two is even, so we'll return true for this test case. So likewise, we have to do. Okay, so this is what we have to code it out. Any confusion here? Till now, do you guys have any confusion? I hope there is no confusion. Let me just quickly code it out. So what we can do is we take the element to explore its childs, right? So auto temp is equal to q dot run and q dot pop, right? Now we have to explore its all the this eight direction, right? So what are the eight directions can horse can move? Let me just quickly vector of where direction, right? So these are the direction like so minus this is in a vertical, right? And this is a y direction, this is x direction. So plus one minus two plus one minus two and plus one, right? Then minus two minus one minus two minus one, right? So we have covered this two. Now let's cover this. This is back, right? So in x direction we are doing. Oh, sorry. This is x coordinate. This is y coordinate, right? So what we have to do here is wait. Let me just start from beginning. So, so I'm relatively we have to write here, right? Relative order I'm writing. So this is in y direction it's minus two plus one. So x is plus one, comma minus two. Okay. Now for this point it is again minus two in y direction and minus one in x direction. That is minus one minus two. Okay. Then let's cover this 2 point. This is plus 2 in the x direction and minus in the y direction. That is 2 and minus 1. Again, this is plus 2 and plus 1 and 2 comma 1. Okay, so we have covered this point, this point. Let's cover this 2 point. This is uh, plus 2 in y direction and plus 1 in x direction. I'm confused now. Wait. So this is too confusing. Wait. This is our, see, this is a positive, this is a positive direction because I'm considering this is the origin. This color is not good, something like red. So if I take this is the origin, and if I consider this is the positive direction for me, this is the positive direction, and this is the negative, and this is also negative for me, right? If something comes here, it's positive. So this will a good reference for me. Okay. So let's rewrite the points again. So what we can do is, thanks, Aditya, for joining. What we can do here is, let's first calculate this 2 point. So for this, if I take this, this is the origin for me, and if I want this point, if I break it down like this, okay. So everything is positive here. This is positive, negative. So you can compare this two as the same. So now we need a relative point. So for let's cover this 2 point. That is in a y direction that is 2 minus 2 and plus 1. So 1 comma minus 2. This point is plus 2 minus 1. And this is 2 comma minus 1. And let's cover this point. That is y में plus y में 2 and x में 1, right? So y, this is both negative. X is 1, y is 2. So both is negative, minus 1 comma minus 2. Then if we take this point, that is 2 in x, 1 in y. Both are negative, right? This quadrant. In this quadrant, both are negative. So x is 2 and y is 1. X is 2, y is 1. Okay, so we have covered this also. Now came to this quadrant. This quadrant, y is positive, x is negative, whatever the absolute value. That doesn't matter. So if we want this point, that is x. In x we have 2, y we have 1. Okay, so x is negative. That is minus 2 and 1. And for here, there is again 2 in absolute value of y is 2 and x is 1. This is x, right? That is minus 1 comma 2. So we have covered 6 point. 1, 2, 3, 4, 5, 6. Now we're left with this. Everything is positive here, right? 2, 1. That is 2, 1. And we have 2. This is y may 2, x1. That is 1 comma 2. So we have covered all the 8 points where horse can move, right? These are the 8 points, relative 8 points where horse can move, right? I hope I didn't make any mistake here. Otherwise, everything is fine. Everything is fine. So now let's explore. Let me just remove it. So we have TM, right? So what we can do is see, this is an easy problem and I make it as complicated as possible. I don't know like this is the intended solution or not. See, traversal doesn't require for this easy problem. Whenever you see a easy tag, if you're thinking something complicated, that means you are not in the right direction. That is the first indent telling you like you are not in the right direction. But for now, I don't know like what's the correct easy solution for easy problem. This is not a correct solution for easy problem. Mm, what we can do is let me solve this problem later. We'll do brainstorming. See, this is not an easy solution for it. This is definitely not a beginner friendly solution, right? It require a understanding of a traversal. If I'm able to, if I code it also, if I code it out here, you will not able to understand. If you are unable, if you have not solved any traversal problem earlier. So for now, let's pause this discussion on this question. We're skipping this for my understanding. Skipping second easy problem and trying first medium lead code question. Okay. Now, do we have an audience or not? For we have a today's India's match, right? ODI. Maybe that's why people are not joined the stream, but it's fine. Let's move to the first medium problem of today's first medium problem. So this is the today's first medium problem. Let me just start then. Maximum value of an alternative sequence. So what question is saying? You are given a three integer n, s, and m. A sequence of integer of length n is considered valid if s of 0 is s. The sequence is alternating, means that either S0, S1, S2, okay, or this, okay. For every adjacent pair, their absolute difference is less than equal to m. A sequence of length 1 is considering alternative. Return the maximum possible element that can appear in any valid sequence. Okay. So we are free to choose any sequence, but the constraint is sequence to start with this S. That's the main constraint we have. Now we can build any sequence, and another condition is the absolute difference between two adjacent pair is less than equal to m, and we have to tell what's the maximum. See, what's the maximum? Definitely, say if you take the absolute difference, what's the maximum element you can bring up in this sequence? That is what they're asking. So it's easy, right? So why it feel easy? First of all, see, they told you to bring. You want to make has maximum has. Uh, the, see, the question asking is to find the maximum possible element that can appear in a valid sequence. This is a one of the valid sequence, and we want any one of the elements should have go as max as possible, right? And and the first thing is the first element is fixed, right? S is fixed. So if you want to make the second element as max as possible, what's the option you have? You have S plus 1, you have S plus 2, you up till S plus M, right? You can't put here S plus M plus 1. Why? Why we can't put this element? Because if you take the absolute difference between these two elements, then you end up with this 1, right? 1. For example, say this I am trying to explain in a general fashion. Why? Did you got my point or not? For the second value, because of this difference, we can't put something that is more than S plus M. Maximum thing we can put here is S plus M, right? So this is my claim. If something is uncleared, then I can explain further. Others I can code it out. Because of this difference, we can't put here this is not allowed, right? So the maximum value you can put here is S plus M, right? And what's the maximum value you can put here? What's the maximum value you can put here? That is add plus M here. That is what you can put here. And what is the maximum value you can put here is add plus M. This is my observation. It might be correct, it might not correct. So let's validate this. Does this correct or not? So according to this, let's say we want four elements, right? And we have to start with three. And the maximum difference we can put between two elements that is should less than equal to 5. So what we can do plus 8 plus 5 we can 8. So if you can take the difference between those two elements, you will definitely get 5, right? And this is allowed. Now next element what you can do is put here anything like wait, why 7? The maximum element in the sequence is 12. Oh, we need to form one more condition. See, we can't add plus MMM. This is not correct. We have to make it alternative, right? So this is like this, right? Now we have to make something this. So what we can do is just one element smaller. This can serve this purpose, right? This can make the sequence alternative also. And now again, what you can do is add plus 5. And should take the difference between these two is that is also less than equal to 5, right? Because the difference is 1. here add 5. That is 12. And you can say 12 is your answer, right? And this can, so this is also an alternative sequence, right? This, this we have satisfied. This is also we have satisfied because every difference you will see is always less than equal to 5. This condition is also satisfied, and we can return this is our answer. 12 we can achieve, right? I think I have explained in a hurry. I hope you guys can like you guys have understood correctly. If you have any query, do let me know. What we can do here is let's say long start is equal to s, right? So and let me take bool is equal to 0. If bool is 0, that means I will add plus m. If bool is if OK is 1, so what I'll do is for int I is equal to 0, I is less than n, I plus plus. If OK is if not OK, if OK is equal to 0, that means I will do start plus is equal to m. Else I will do start minus is equal to 1, and I will return the start. Here, wait, what just we can debug this, right? So we start with 3. Wait. We start with 18. Why 18? Wait. We start with this 8, right? We have to change. Okay is equal to not okay. And yes, because already we have to run this for loop for n minus because this is our start element, right? We have to process n minus 1 element, rest n minus 1 element. And yes, so that's the solution for this question. Let me submit. We have a wrong answer here. Why? Where we have wrong answer? Start is equal to 7, n is this. Ah, so this is one of the edge case. Say you can form sequence like this, right? Or you can form sequence like this. So you have to observe. So for this sequence, what we did here is for to satisfy this condition, we did a plus n here, right? And from here to here transition, we did minus 1 here. So we want our element, the start element, we start it with s that can grow as much as possible at the end, right? So we have to observe like we want to include as minimum as possible minus 1 in the answer. Right? So what you can do is instead of plus m, you can start with like this also minus 1 plus m minus 1 plus m also, right? And whichever gives you a maximum answer, return that answer. That can be also possible, right? So I have tried to create this first, right? I have tried to create this first sequence. Let me call it answer 1, start 1, right? And let me also build the second sequence. That is also possible, right? We can build any one of the possible sequence. Okay, and here minus 1 or plus m. And let me call it as a start 2. And whichever is the maximum will return that max of start 1 comma start 2. And let me use this test case also. Wait, what the fuck? Okay. Okay. Yeah. Whichever will maximum will result a maximum will return that. Wait, what just happened? Long, long. Wait, still I'm getting 13. Hmm. Now we have to look into approach. Say we have three element, right? That means we can build one element, two element, three element, like this. Okay, or we can build like this also. Okay, and this element is fixed. That is seven. This is fixed. Hi Tejas, how are you, man? Okay, so should I summarize the what question is, or should I continue? Everyone is on same page. Just let me know quickly. Oh, oh, Jana, Jana. Okay, so what we and we want here, see, we have to keep in a mind to for like we have to satisfy this condition also. So here, if we want a greater than, so what we can do is we can add 14 here, right? Or we can make 6 here. And now we have to satisfy this, then this becomes 13. We have to satisfy this. If we have end up at 13. That's correct. We want 14 our answer, right? That is what the expected answer is. Then what I'm missing? Am I missing anything here? No, right? How 14 is possible in this case? We want three elements. We have to follow the alternative sequence. Hmm. How 14 is possible? Wait, let me just think for a while. How 14 is possible here? Difference between these two elements is 7. Difference between these two elements is 1. Okay. Difference between these two elements is 1. And difference between these two elements is 7. Yeah, 13 is what I am able to achieve. I'm missing anything? I seem like I'm missing anything. What I'm missing then? 13 is what I'm able to achieve. Wait, what I'm missing? Wait a minute. I got a call. Wait a minute. Let me just quickly reply to this call. Okay. What I am missing. Does anyone have figured out what I miss here? We want see, start element is fixed. So 7. For this case, 7 is our start element. Okay. Now let I have built both the sequence. Okay. If I want to make and my goal is to achieve maximum possible element. So I will decrease as small as possible and I will increase as maximum as possible, right? Greedily. This is like greedily if we think. So this is the possibility. Okay. And 13. Okay. Ah, fuck. 14 is the answer, right? Wait. See, this is what the main misconception we have. See, we read question correctly, but we have not understand the question correctly. They are not asking what is the last element you achieve. They're asking what is the maximum element you achieve in your entire sequence. That is 14, right? So we have to write, like we have to return 14, not 13. You see, we have achieved 14, right, in our entire sequence. Fuck, how I missed this. So instead of this, let me just quickly long answer is equal to 0. And in answer, I will keep track of maximum elements so far. Fucked up. I just fucked up my time, not realizing the silly mistake. Okay, and here also. And simply return answer. And let's submit. And we fucked up again. Answer should be S, right? Because first element is this. See, these are the silly mistakes. I'm showing you here that we have to avoid. I have to avoid in my contest. And let's submit. And we fucked it up in a time complexity. Wait, why TLE? And then as we can do this mathematically, we don't even need this for loop. If you see a pattern is repeating, right? See, constraint is too huge. Biggest mistake I'm doing right now is I'm not thinking of an edge case. I'm not thinking in a term of constraint. So these are the primary reasons you have to look while you're solving any problem. Otherwise, we will end up in such a silly and idiot mistakes that you saw here right in front of me. See, we know, right, what's the maximum element we can achieve here. And if you start with S and you will do here S plus M, then you will do minus 1, then that is S plus M minus 1. Then you will do S plus M minus 1 plus M. So what you have noticed, if this is an even number, if this is a even number, then you have n by 2 m plus m, n by 2 plus m. You have noticed here, n by 2 time we have did plus m. If n is even, if just observation, you just need to apply observation. You see, if length is even, so what you have noticed here, we have n by 2 plus m and n by 2 minus 1 time we did minus 1, right? And if you have a, this is about, for example, say we have a even length. And what if we have a odd length? If we odd length, then we have s plus m. This is our second element. Wait, let's not make it up. See. I got it. What we are trying to do here is, let me just summarize here. See, n can be even and odd, right? So let's break down. N can be even or n can be odd. Okay. If n is even and first element is fixed, both the case, right? Right. So what is the second element? That is s plus m. If we try to build this kind of alternative sequence, then what is this element? That is s plus m minus 1, right? Now we want this. So again we do s plus m minus 1 plus m, and it will continue 4. So n is, and if n is odd, then let me add one more here. That is, now we want this, right? So we'll do minus 1 again. So what observation we can make here is, see, this is definitely the largest element among all of this, right? And if n is odd, you will see this is second last element is the largest element, right? Because this is the same here and here. This part is same, but here we did minus 1, right? And if you notice this, so this is the largest element and this is the largest element. So how many time we did plus 1 here? Plus m, that is n by 2. Plus m we did here n by 2 times. N by 2 times. And minus 1 we did here how many times? 1, 2. 1, 2, 3, 4. 1 time, right? And let me make more generalized. If we add more term, we'll have a clear idea. Here we did minus 1. Then we want to make this. So we'll do plus 1 plus m, right? And we bring this more. So now we have clear idea, right? So this is the maximum element here, right? So 1, 2, 3. This is sixth term. So we did 3 times plus m. And how many times? N by 2 minus 1 time. N by 2 minus 1 time. We did minus 1. So we'll get this maximum element. Now if we do some observation, if n is odd, so what this is all, so you see this is our maximum element. That is we have to, and to make it more visually correct, let's me add few more term. We have to make this greater. We have to do plus 1 in this term. So we did plus 1 and we want to add one more. We have to do minus 1 here, right? Because we want to satisfy this inequality. What we'll do here is we'll do minus 1. So this is the maximum element, right? So let's see what we have to add and minus in our S. So how many times we did plus 1? In this you will see 1, 2, 3. How many element we have? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So it's a floor division of, so plus 1 we did here is also n by 2 time, right? And minus 1 we did here is 1 and 2. That is same. N by 2 minus 1. 1, 2, 3, 4, 5, 6, 7. 7 by 2, that gives us a 3. That is 3m, right? And n by 2 minus 1, that is the 3 minus 1, that is 2. That means we did here n by 2 minus 1 time. So this, you will see the claim we are making is same for odd and even cases, right? This is what my observation is. See, we are making the claim. What we have observed is same. N by 2 time we do plus 1 and minus 1 we do n by 2 minus 1 time. So that is my final. So if I want to build my answer, that is max element. How does it look like? S plus n by 2 time I will do multiply by m minus how many 1 I will minus plus I will do n by 2 minus 1 time minus 1. Okay, and let me make it let me 1 ll to just to convert integer into long. Wait, what is that? And here also 1 ll, and we'll return this. I hope this should work. So it is working for most of the cases, and let's debug why it's not working for n is equal to 1. See, n is equal to 1, then we don't need to do any such thing. S is our direct answer, right? If n is equal to 1. So why this doesn't work here? Let's just see. So S n is equal to 1, then 1 by 2. This should become 0. This should become 0, right? Yeah. So actually we want to take max of this from our 0. Wait, what? Okay, let's not make it long here because anyway we are doing typecast here, right? Good ye menu sari khabar. See, it is working, right? Let me, we are getting time limit exit here. Let me just use this. See, now we have converted our entire solution into order of one. We are not doing any computation, right? We are just using arithmetic operation. And let me just submit. And you see, we get accepted. So this is how you should approach in contest. I shown you how many like I would bring you right from wrong answer to TLE to accept. We'll see like how observation help us to crack an order of one solution here, right? Any confusion or doubt do you guys have? And let me first quickly, meanwhile, update the status. Problem solved is this. Solved, trying second medium. Okay, so we have solved first medium question today. Where we have solved this. Now I have to pick first medium question from weekly contest. Should I move to the second medium question or do you guys want to ask anything? Please go ahead. No, 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 no. Redo, wiki cuto. The fuck is going on? Okay, so there's no question. Let me move to the second medium question of today's second medium question. So the question is Your the question name is count dominate dominate. Okay, node in a binary tree. Okay, so the question is you are given a root node of a complete binary tree. If you guys don't know, complete binary trees means every like you don't have one child. You can have a zero or two child. A node X is called dominant if the value is equal to the maximum among all the node in a subtree. Wait, what? Acha. Okay. So see, phi is not a dominant node here because there is something greater than phi in its subsequent subtree. That is 8. 8 is a dominant node because you will see there's 7 and 1. There's nothing greater. So let me mark. 8 is a dominant node because if you look behind, like if you look in its children tree, you'll see nothing is greater than 8, right? So 8 is a dominant tree. 3 is not because there is 4 in subtree. 3 is not. Every leaf is a dominant node. The question mentioned that every leaf is a dominant node. So two, so one, two, three, four, five. So for this test case, five is the answer. Let's look at the second. Let's calculate here how many dominant node we have. One is not because three is in a subtree. Two, oh, it's strictly greater or what? X is a dominant if the value is equal to the maximum value among all the nodes rooted at X. Okay. So what is the maximum value for this two? Two is the maximum value. So there is nothing greater than two in its subtree. So we can consider this is one. Every leaf node is a dominant node. So four is our answer. So that's what we have to calculate here, right? So what we'll do here is, if we want to know this node is a dominant node or not, so what we can do, what is the maximum value from this subtree? What is the maximum value from this subtree? Let's say this is M1. Let's say this is M2. So this one should greater than equal to M1, greater than equal to. This both condition is satisfied, then we can say the current node is a dominant node, right? If we have a tree like this, there is a subtree here. If we have a tree, so we have calculate it from what is the maximum value. Let's say that is M1. Let's say this is M2. Then we can say this. If this condition satisfied for both M1 and M2, then this node is a dominant node. So this is what the equation tell us. The current node is a dominant node or not. So this is what we have to calculate. Okay. And every leaf node is a dominant node. So what we can do here is let me just quickly code it out then. If it is cleared. So what we can do here is I will calculate answer. Okay. Now for each node, let me call return solve. Let me pass root. Okay. Yes. And int solve. I have a root. Okay. So first of all, I have to check if root is a leaf node or not. If it is a leaf node, we'll return plus one. If wait, if it is a leaf node, we have to return every leaf node we have to count and what is the maximum value, right? So current. So from left, if left node is present, if root left node is present, max M1 is equal to 0. Then M1 is equal to how we can code. Wait, this is a long time back. I have coded some tree recursion solution. You want the maximum value, right? Okay. So let me call it as a get maximum. What if it is a root node, leaf node? Okay. If root left is null, if and that means it's a leaf node, right? If root left is not present, root right is not present, that means it is a leaf node, then we have to return the value of root. And let me call it get max. Okay. Then we have to return root value. Okay. And if max, let me call it as max. Max is equal to maximum of max comma get maximum of left root. And if right child is present, and then we can say get maximum from left, right. Okay. Now we have to return what we have to return, that is, select calculate the separately int answer. Okay. So this function will return what how many dominant node other than leaf node. So what is the condition, that is current root value is greater than equal to max, plus if this value is true, then it will add +1 to our answer. Then calculate for root left and calculate for root right. Okay. So according to this question, we should have 1 because we have not added these values, right? So let me see, are we getting 1 or not? Root value, VL, okay. And we can do like this also. Wait, if you want to include this also, then we can add like if both are null, right? And this is also null. That means this is a root node. But this will change the definition of this function, right? This function return the maximum value, not tell. Okay, so we'll calculate separately that thing. उसका show ना bro कोड दिख नहीं रहा size increase करो. Okay, okay. It is not visible, right? Wait, I think I have to increase the font size. How can I increase my font size? It is visible. Utkarsh, can you confirm it is visible now? I think it should visible now. Okay, thanks. Thanks, man. I'm expecting 1 year because till now I haven't calculated the leaf node. I've just calculated the dominant element in other than leaf node. Okay, and we have fucked up. We should return 1 year. Ah, got it, got it. Okay, okay. So problem is this is one, but this return a maximum element right here. It written 8 instead of this. Hmm. It should return 1 or 0, then it can serve a purpose. If it is not null, this is also not null. Wait, we have to change the definition of this function. This function should return 1 if the root node is a dominant node or not, right? Yeah. So what we can do is we can call this function as a solve function. ब्रो आपने लिस्ट कोड के तक सारे क्वेश्चन नहीं ब्रो not let me tell you how many question I have solved around 1,000 I have solved wait how many question I have solved I have solved around 932 problems bro this many wait let me just change the definition of this function let me call get dominant get dominant okay if I pass root and let me create one more function get max. If I pass root, the purpose of this function is to get what is the maximum element from its right subtree and the left subtree. Okay, and this function tells me if my current is wait like this and left max left max that is get max. I will call get max and I will pass root left right max. Now this is quite cleaner code, right? Right. And this. If my left max, if my root value is greater than left max, and my root value is also greater than right max, then this is a dominant. The current root is a dominant, right? The point is we want to count for each. We need to put a iteration. Say we need to solve a recursively. We have to go depth. For example, say if I take Manu, hi Manu, count left, right. count one, left max, count two, right max. Yeah, this is what, see, the easiest way is to solve for each element, you should have what is the maximum from its subtree, right subtree, left subtree, right? And this is a dominant element, so it should return how many dominant element we have find out from this with the count of dominant element from a subtree, count of maximum element. This many information we should have at each point. Then we can easily solve this problem, right? Yes, yes, yes. But the point is how we can implement this easily. I want to implement this anyhow. Wait, this is the I completely forgot the trees. Like tree is the easiest topic. See, it just required it first go. It looks too complicated. See, for me also, it's looked too complicated, right? But I saw lots of tree problems. That's why I can tell you my experience that tree problems are quite easier if you like. If you should not get confused. It's just this many functions. Like you have to break down your code into a smaller function, and each function should have a specific work to do. Then it's quite easier. Right now, I'm struggling because I left the practice of for tree problems. So see, for each, if you look, say, for the each node, if you have information about what are the information, what is the maximum element from its subtree, and how many dominant elements, let's say the count. If you have this information for this node, you can use that information, right? And at the root, you will have the total number of dominant elements, right? So let's just code it out. Get dominant get dominant element. Okay. So we'll pass the root and right now we have zero dominant element. Okay. And we have to solve it recursively. And here we have to do plus uh, or do we require this count? No, right? Wait. I guess I have not added root left plus right. Okay. And what is the purpose of this function? To get the maximum element, right? Yes. And how we can solve it? Let's say current max is zero. If we have if root left is null and root right is also null, return root value. This is for leaf node, right? Else if root left we have, then max is equal to maximum of max, comma root left. Similarly for right, 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 and we return max. I hope I didn't make any. Till we haven't counted the leaf node. Wait, why still we have an error here? If this is a root node, then return root value, right? Wait, what? Member access within null pointer. If it is a null, then I'm not accessing, right? Wait, something is popped up here. Runtime error. Why runtime error? This is a leaf node. Do we miss anything? Did anyone find why it is the left is null, right is null, then we return root value. Do you guys, anyone saw what's the cause here? Why I'm getting runtime error? Stating कि I am accessing the null pointer, but how? I'm not accessing the null pointer, right? Member accessing within a null pointer of type T node. Okay. If root is null, return zero. Still, wait, where? Ah, here also we have to put if root is null. These are the edge cases. Return zero. And we have an answer here. We have answer, right? I didn't see any clause here. It will pass. What do you? I'm feeling confident. I don't know. It can fail also, right? But did you guys notice like how we have break down the problem into smaller function and we have like at least we get pass sample test cases, right? And I'm feeling confident. Like for each, I'm calling number of node can be 10 to the power 9. It may fuck. We end up in a time limit exit here. Possibly. No. Number of node in a tree can be 10 to the power 5. And we run a recursive function here, right? Yes. So we need to apply DP here. It will give a time limit exit if I'm not wrong. Because for each node, we are recalculating, right? We are not using the computation. For example, say, yes, we are not, for example, say we made a call for this function also, we made a call for this function, this node also. So we'll end up in a time limit exit. That is what I'm suspecting. Let's just give a submit and we'll see. No, wrong answer we are not expecting, right? Time limit, something is wrong then. Logically, something is wrong because we are getting wrong answer. Why we are getting wrong answer here? Let's just count. Three, this, and this. Three is the answer, but we are getting what I'm getting. 4. Why? Why? Let's debug. If you, if, I don't know, like why it is failing. So let's just debug. This is my root value, and these are my left maximum and right maximum. This is how, this is how, this is my left max, and this is my right max. And we'll see. Oh, see. Where is that tree? For 4, it should be 15 and 4, right? But I'm getting 4 and 3 and 4. This is not true. Let me first draw this tree for a reference. We have a 4, we have a 15 here, we have a 4 here, we have a 3 here. But 4, we are getting 3 and 4. 3 and 4. That's not true. Here we have to return max of max comma root value, right? Yes. Now you'll see for 4 we are getting 15 and 4. From the left we are getting 15 as the maximum value. From the right we are getting 4. So then 4 will be not our dominant, right? So let me just submit. Now it should give time limit exit because if I'm not wrong, for we are making a this we are not reusing. I have not like if you saw here, we are not storing the computed value if we want to use in the future calls. So DP is the potential optimization should come here if we get time limit exit. Fuck, it got accepted. I don't know. I don't know. I think it should give time limit exit, but it got accepted. Oh, we have a we re okay, that means this is the optimal solution. Wait, if I want to calculate the time complexity, we have n nodes. For each node, I'm doing a function call. And should give time limit exit, right? Uh, but anyway, I'm not sure what the time complexity of this. We can use this, right? Wait a minute. The time complexity is n square, but I got accepted, right? That's why I'm also feeling it's n square time complexity. Use my logic and return count 1 plus count 2 and plus 1 if root. See, this is the working solution. I completely understand order of n. This what's the time complexity of this solution? This is also order of n, right? It is not order of n. Yeah. What's your suggestion? Return count 1 plus count 2 and plus 1. What is count 1 and count 2? Oh, this that is what I did here, right? Say, if root is greater than, and this is count 1 and this is count 2. This is what you are telling, right, Manu? That is what I did here. Oh, that's why it is order of n. Okay, yeah, yeah, got it, got it. So we're calculating the child, what is the max, what is the count of dominant element we're getting from left child? What is the dominant count from the right child? That is this. This function will return that count. And we are checking if the root is the dominant element or not. Ah, I see, I see. Yeah, this is the optimal solution. Got it, got it. Everyone is on the same page, right? Do like the string, guys. Do like the string. This is what I did, right, Manu? Count left max, count to right max. Solve root left, solve for root right. Wait, what I'm thinking is the, the way you are suggesting, that's what I did here actually. This is solve for me. See, wait, let me give you a terminology. The sol you're telling me is this is the sol function. I'm calling sol as a get max, right? The sol is on left, sol is on right, and this. Return two value from one function. Return two values from one function. Yeah, I got your point. I just want to know the time complexity of my code. Wait, it's order of n square, I guess. Yes. Let me just confirm quickly with ChatGPT. It's order of n square, right? If it is order of n, Siraj Kumar, my lead code ID is direction, direction underscore. What is the, it should be order k, and see, it's order n square, right? But case 2, it's the balance. Ah, got it. See why this works here? Because of it's never a skewed binary tree, right? It's a balanced binary tree. That's why we are not going in a skewed format. That's why our time complexity reduced from n log n. But in see, this is what I'm telling. Because this is the balanced binary tree, that's why the maximum height of this tree is log n. So even though, yes, and Manu, maximum you can go 10 to the power 5, right? Maximum call. If it is skewed, let's make it a skewed. Let's say this. If tree is like this, it's uh, This is not possible. This is not a balanced binary tree, right? This is not a balanced binary. If balanced binary tree should like this only. This is also balanced binary tree. This is also so you'll never have a case like this. If if the question does not mention that this is a balanced binary tree, complete binary tree, then this solution won't work here. The solution I have implemented is only work if we have a complete binary tree. Got my point? The logic is log n because of this constraint. Otherwise, if this is not given in the question, then the problem setter can build a sample test case like this, and my logic will fail here. Got my point? Hello, boy. I'm currently in a fourth year, and my fourth year will start just now. And I am from tier 2 college, but from electronic branch. And for DSA part, my basics are clear, but not graph DP in a full is full left. And I need a good package. Please guide me in which direction to work to achieve my target. See, if someone targeting on campus and your college is good enough to bring the companies, definitely recommended. Firstly, clear your CGPA barrier, shortlisting barrier. That is minimum 7.5 or 8 in some college. In my college, it's 8. If you're 8 plus, so your CGPA barrier is reduced, and you definitely sit for all the placement, right? So first part is done. CGPA you have cleared. So CGPA shortlisting. It's mandatory and it's always happened in college placement. The second thing is for the on-campus placement, the mostly questions revolves around core subject. That is OOPS concept, C++ concept, DBMS concept, OS concept. Okay? That is also clear because that's your curriculum, right? Then the third part is the DSA. So if you're targeting your on campus and there's a good enough placement is going, like your college is giving you an opportunity to sit for a good company. So to prepare a Stiver sheet, that's more than enough. If you completed the Stiver sheet, then only you can look for a different. Just follow a sheet, big wise sheet. Sheet has a topic-wise concept and it will cover all the aspect, easy, medium, and hard. And I recommend to go with a Stiver sheet if your complete focus is on campus, a good placement. Because I did that, most of my friend did that, and we have achieved a good result. Right? Manu has an interesting example. Let's consider three node tree. So first go left and then in a single node. So return one, that's it. The value and then go right the same and after that check the root. Yeah, I got your point. This is the optimization, but I'm not still not convey. Will end up in a same time complexity if I implement like this also. Don't you think so, Manu? We'll get a same time complexity if I implement like this. Sorry, guys. Amanshu, I answered your question, right? Yes, CGPA is clear. My college has sample, and I did Stivers A to Z, and I did around 250 from it, and I also want to try for off campus. So, what things are required for off campus, like DSA level? If you answer this, if you're targeting off campus, then you need to start doing competitive programming. And because if you have good command on competitive programming, see, you have mentioned you're not like confident enough for DP and graph, right? So for complete the Stivers DP and graph section. I've solved all the DP questions from the Stivers sheet, and I'm pretty much confident. Like I'm able to think. At least if I'm not able to solve question, I'm able to understand the DP solution and the graph. I followed the Stiver sheet for graph and DP, and that's helped me a lot. And for the off campus, you have to build your confidence. So you have to start giving a live contest. Anything you can add coder beginner contest every Saturday we have at 5:30 p.m. Then attempt code forces contest at least div 2. Then attend code chef contest that's happened on Wednesday. The live contest builds your confidence. So that's help in off campus. Like off campus is you have a huge competition, right? And the contest itself now this will competing with 1,000, 2,000 candidates, 20,000 candidates, right? No, it's only order of n, not n square. Okay, okay. Let me implement your solution also. For the time being, let me just update trying second trying optimization. Optimization. Okay. So what you are suggesting, Manu? Can you please help me? So the point is, let me just quickly bring. No, no, that will hide my camera. Will hide, right? It's fine. Don't call me Sir. You can call me Viren. Okay, okay. So the optimization is, can we bring this to an order of n? So for that, what we have to do is, wait, what you are suggesting me? Let just make an observation. How we can actually. So I made a call for this function, right? Then I'm solving for this, and I'm solving for this. Okay. Then I made a call for this function, right? See, this is a order of n solution, right? Why I'm confused. This is order of n solution, right? No, this is n square. Ah, got it, got it. So we have to get rid of this function. How we can get rid of this function is we have to return count. From this function, we have to return count and the maximum value. Yes, true, true. This is n square solution. Yeah, because this is order of n because we are visiting each node in the tree. And for each node, we are again making a order of n function call here. This will run in order of n, order of n. This will also run in order of n. So eventually we will end up in n square solution. So this will O of n square, right? So we have to get rid of this thing. And how we can get rid of this thing? Yeah. So we have to return maximum we have seen so far. And for that we have to think. I have to think because I'm confused now. How can I return maximum? So maximum what we can do here is okay. So what we can do here is left max, right max. And we have to pass two value here. Left max is 0, right max is 0. Okay. Let's say I will not call this function anymore. And we are passing this. Left max. Yes, yes, I got your point. Yes. We need to pass two function, left max and right max, right? So what I'm trying to do is I'm making my function optimization. So whatever things like for example, I'm calling this function, right? But instead of calling, I will keep track of this function, track of this value. Okay, left max, right max. Okay, so everything else I don't need to change here. So what I have to do here is, or we just return the count and this. And here we have auto answer comma max. and this will return a vector of int. Okay, and will return answer of 0 here. Okay, cool. So now what we'll do here is we have auto. We'll call left on left. Let's call it left. We will call left here, and here we'll just maintain a max. Okay, and we'll call for root left and max. Then we'll call auto right. We call on right with this max. Okay, and what we return is what will return here. Okay, will return this thing. If root value is greater than max. Hi bro, how are you? Hurry, I call it hurry. Okay, plus count one, count two. What is count one? That is left of 0. This is vector, right? So what I'm storing in this vector is count and maximum value plus right. How many dominant element I get from left subtree? How many dominant element I get from right subtree? Okay. And anything else we have to do here? Wait, but we are not updating the max anywhere, right? How we can update the max? We have something is fucked up here. Wait, wait, wait. If it is a root node, if root is null, then we return 0, comma max. I'm not updating the maximum value anywhere, right? I'm calculating here this, I'm calculating here on the right subtree and left subtree. I'm passing the max is this. Wait, how can we handle the max here? How we can handle the max here? And if it is a root node, yeah, we have to write this logic here. If it is a root node, okay, okay, wait, wait, I got it. If it is a root node, then we have to return 1 comma value of that root node. Okay, that will be my max value. Okay, yeah, this is fine. If it is a root node, see, if it is a root node, so what are the information we passing to a parent is one dominant element, me itself. I am a root node, that's why one dominant element, and the maximum value from my subtree is 2. And for this 4, what we are doing, I'm returning 1 comma 4, right? This is what this function do here. That's it, right? This how we can update the max. And we have to return. This is our count, and we have to return the maximum value. That is max among all three. Root value, then left of 1, then right of 1. Yeah, now we can say we are handling the maximum value also. Okay. Answer is equal to auto. Wait, we have solved something, but this is not order of n square. We will calculate what is the time complexity. Wait, let me remove this first off, and we are not using this function anymore. Okay. So where is the mistake now? See, I pass root and zero. Okay. So I call for five. I made a call for five. Okay. Now I'm solving for this part and this part separately here. Max is zero till max. See, let me just quickly write down. So I made a call till now. This is in a hanging state, right? We are here. I made a call for this also. This is also in three. The call for three is in the hanging phase. Now we are at this, right? So root is not null. Root is not null, right? But root left is null. Its root left is null, and root right is null, right? So this is leaf node, so it will return 1 comma 2. So we have written here 1. This is 1 comma 2 we have written. Okay, cool. So now we came here. Okay, so here we have 1 comma 2 in this left. So now we made a call on a right, then yeah, from here also we get 1 comma 4, right? 1 comma 4. Now we are at here. So 3 is not okay. So 3 is not greater than max. Ah, I see, I see. So we have to calculate, max is equal to current max. Let me call it a current max. Max is equal to max comma left one comma right one. Right. Cool. Something, this is what we have to do. Something like this. Yeah, and we have, right? So what the error here is, see, I told you 3 is not maximum because we have to compare this 3 with its left max subtree maximum and the right subtree maximum. Right. The current maximum is among the these two. Even though if I don't use this max, yeah, it still works. We just need to compare with these two values, right? And for its subsequent call, for this call, we need to pass the maximum among these three values, 2, 3, and 4. And that is what we pass here, right? So instead of this, current max, and yes, that's how we can converted this into order of one solution and solution, right? Because you will see we have visited all the nodes once and we get rid of this function. So I hope this is the order of n solution and will pass all the test cases. Let me submit. And we have accepted solution, guys. And we did it. Done optimization. This is a happy moment for me. Did optimization on second problem also solved. Solved and did optimization. Guys, I don't know. I'm feeling happy right now. Can we make it like I want to align this. I want to align. Do you guys know how can I want to align this from right side? Like it should grow this right. I don't like this white space here. Transform, stretch to screen, center. No, no, no. Alignment. Where is alignment? And one more thing I have to update. We have solved two medium question. We have solved one easy problem. And I want to know, guys, anyone, do you know what's the easiest way to solve this fucking easy problem? This fucking easy problem. Does anyone in the chat knows how we can solve this fucking easy problem? Because in my mind, I'm thinking of some kind of traversal algorithm, BFS or DFS to solve this problem, but this is an easy problem. I don't want to involve any such traversal problem. Does anyone know how we can solve this question without using a traversal function, any traversal algorithm? I'm open to suggestion, guys. Do like the stream, do subscribe if you're new to my channel, and we have interesting live streams in the future also. We'll learn, we'll solve, we'll grow together. That's what my goal is. Hello. This will be on order of one solution. Let me just confirm. We are not using this function, right? So let's just remove this. Say order of n, right? We make a two calls. That's it. There is no nested call. So there is no nested call. So using this function, we have this is just a traversal. In order, I can in order or pre-order, post order, left, right, and root. It's a traversal. We're traversing. We're visiting every node once. That's it. There is no nested calls. I have a suggestion. First of all, thanks till G. It's an interesting name. We can calculate the move by seeing the color. Okay, something interesting. Okay. Or if I'm standing at, oh my God, it's a square of 2 cross 2, right? What's your, we can calculate the move by seeing the color. What that mean? We can calculate the move by seeing the color. What's that mean? Bro, sorry, I didn't get your hint. Should I look the hint here? Color, the chessboard like a standard chessboard using a parity. Okay. Every night move change the color of the current cell. Therefore, okay. Night must be in a cell of same color. Okay. Third hint. Since every cell is reachable from every other cell. Is it? Oh, this is a good property. I don't know about this property. That's why it's very tough for me. See, this is very good. Yes, got it, bro. Got it. I got your point now. But this is the interesting property. I didn't know about this property of chessboard coloring. It's visible, right? Yeah, it's visible. So this is one of the interesting property and I don't know about. See, it's saying that you since every cell is reachable from every other cell on 8 cross 8 chessboard, return whether that's it. This will solve our problem if you know the property of this. I don't know. That's why it seems to very tough for me. So I will skip this question. I will not solve. It's easy for those who play chess. Wait, I'm noob in chess. Like chess dot lychee chess. Anyone want to play chess with me? Let's see. I'm good or bad. We'll see. Should I? Oh, I know. I didn't know about that property, bro. Let me play 5 minute chess. Oh, my camera is hiding, right? Let me change the camera for a while. Okay. Should I move the knight here? Guys, do help me. I'm not good at chess. Please help me, guys. I don't know. Wait, fuck. No. My queen is in danger. Ah, ah, fuck, bro. Fuck, fuck. My queen is in danger now. मैं ऐसा क्यों हूँ मैं ऐसा क्यों हूँ What do you guys think? I will win or lose? मैं ऐसा क्यों हूँ देखा Oh my god. Oh my god. मैं ऐसा क्यों हूँ मैं ऐसा क्यों हूँ मैं ऐसा क्यों हूँ Should I bring my horse into the game? Oh my god. मैं ऐसा क्यों हूँ Okay, so the point is I can do check. मैं ऐसा क्यों हूँ मैं ऐसा क्यों हूँ I don't know, guys. I will win or lose. Ha 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 ha. Bas, that's what we have to do. Make the opponent think like you are a pro, and I won. Anyone from the chat? Anyone from the chat want to play with me a chess match? We can. We can go for it. Why? Why this Kolaweri? Kolaweri? I should try the next question. Otherwise, if there is no one interested to play chess, seems like my audience is more motivated than me. My eyes are you. My eyes are you. Let me try the third easy problem then. Third easy problem. It's the 5 pointer, I guess. It's the 5 pointer. And this is also 5 pointer. Which one I should try? Biweekly or weekly. Both have 5 pointer. We can play. Do you want to play? Gaurav, let's play one chess match. Then I can continue with the problem solving. What's your ID, bro? Tell me your ID. Tell me your ID. Gaurav 5G. This is right. Let me add you. I have sent you a friend request. Just confirm. Just let me know. मैं ऐसा क्यों हूँ मैं ऐसा क्यों हूँ Yes. Okay, so let me just 5 minute wala. Okay, we'll play Blitz. Send challenge send. मैं ऐसा क्यों हूँ Okay, let's start, guys. Let's start. मैं ऐसा क्यों हूँ मैं ऐसा क्यों हूँ Bro is pro player. I'm fucked up. मैं ऐसा क्यों हूँ Bro is genuinely a good player, I guess. मैं ऐसा क्यों हूँ मैं ऐसा क्यों हूँ Simplest way, the simplest way is to get rid of the, you guys know, right? Get rid of the material. Okay, so there's something is going on, and we can do like this. Why I'm feeling like a noob player here? I don't know. I think I'm a noob player now. What should I do now? I'm thinking of something, but that will not help me. मैं ऐसा क्यों हूँ मैं ऐसा क्यों हूँ Wow, wow, wow. That's good move, by the way. That's actually a good move. Let's materialize. Ah, what we can do is, should I trade? Ah, fuck. I fucked up. I should trade instead of this fuck chodi. मैं ऐसा क्यों हूँ मैं ऐसा क्यों हूँ Bro knows he won this match, right? What we can do here is this. Ah, fuck. Why? Bro knows he won the match. ऐसा क्यों है? I have nothing to worry about now. Thing like, uh, to understand my assignment. Bro has understand my assignment. What should I do now? मैं ऐसा क्यों हूँ? अरे fuck, 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 fuck. Bro, I have respect for you. I'm noob. I accept it. I'm accepting I'm noob. Yes, I feel you. Just take this. Just take this. What I can do here is something like this. And bro started hiking me. My ass off you. Man. I can surrender easily. My ass off you. Why you are doing this to me? मैं ऐसा क्यों हूँ मैं ऐसा क्यों हूँ What should I do now? I don't have an option. Let's materialize. Let's materialize the thing. Wait. We can do something. Like, we can do something here. Wait. I got it. I got my point. I think I can materialize. Let's fuck it up. Let's go all in. बावजी दिल से दिल मिला वजी आ गया है देख हमारे घाट I am fucked up, seem like me. What should I do now? You can take my queen, but no, not now. Bro, you should make me a checkmate. बावजी दिल से दिल मिला वजी आ गया है देख हमारे घाट सबकी आन सबकी शान आ गया है देख हमारी जान and I am low on time. Let me resign, bro. Respect, pro player. Huge respect for you, bro. Now let's solve a problem. Gaurav, man, you earn my respect. Bro, you earn my respect. I don't want to get fucked up on time. I did some blunders. No, it's not a nice match. You are a very genuine player. I'm a noob playing a chess after a long time, long time. Mate, guys, just let me know. We'll solve one problem. Which problem I should try? Bi-weekly or weekly? It's a 5 pointer anyway. Thanks, Gaurav. By the way, it's a good match. After long, I played a street match. Street. It's a street match for me. मेरा तो 200 है. I have 200 elo, right? That's define the level. You're pro than me. Avajit. Will. Guys, just let me know which will start solving. Say we have fuck. We have two 5 pointer. I'm not sure I'm able to solve or not, but we can at least give a try, right? Let me solve this. It's- There's no, there's nothing much I can wait more. The problem name is minimum adjacent swept to partition array. Okay, minimum adjacent swept to partition array. You are given an integer array nums. Oh, you are given an integer array nums and two integer a and b such that a is less than b. Okay, an array is called good if it can be split into three continuous parts in this order such that every element is first part less than a, every element in second part is in the range of a and b, every element in third part is greater than b. Any and any of the three part may be empty. Okay, may be empty. In one adjacent swap, you may swap two neighbors element. Okay, return the minimum number of adjacent swap required to make a nums good. Since the answer may be very large, return it with modulo. Okay, so problem statement is quite simple. It's like if we have an element, we have to split into three parts. Everything less than equal to A. Here everything is greater than equal to B. Here everything between A and B. I'm thinking we have a similar question from code forces, one of the code forces contest. The question is number of one is greater than equal to number of twos and three. Here number of one and two is greater than three and here anything. Ah, ha, ha. What we can do here is what we can do here. And we want a minimum number of steps to perform this. And let me see the constraint. And constraint is pretty good. We need some kind of optimization algorithm, we are saying. Constraint is not low here, constraint is a pretty high. So what we can do is, can we do binary search and answer? See, we have an option here. It can be a DP problem also. I'm not sure, but I'm suspecting it can be a DP problem also. It can be. Because every point we have a choice. Can we make a split here or not? Can we make a split here or not? right? It is a DP problem. Yeah, it is a DP problem then. See, at every point we have a choice. Can we make a split here or not? Can we make a split here or not? Likewise. What we can do is we can stop the stream here and I can do another stream because it's my dinner time. I will not get food after my PG. I will not get food. Right. I have to stop the stream here and it's a pretty good discussion today. It's not bad. It's try too easy to medium. Right. Guys, make it 290 subscriber. Currently, I have 289. Can anyone can subscribe and make it 290? If you have not subscribed yet, I want to see the transition from 289 to 290. Can anyone subscribe? Uh, it will be good to watch. Hoja 290. Can anyone make it 290? Just subscribe. Please subscribe. It will turn into 290. I want to see 290. Uh, it will not. It's not that easy. Understand? So today we have solved two easy problem, two medium problem. So four problem, right? It's done. Oh, 290. It's 290, right? It will take time to update or what? Ah, my God, 290 finally. Thanks, guys. Thank you so much for joining the stream. We'll have a stream most probably tomorrow. If not tomorrow, yeah, we'll have a stream tomorrow also. We'll try to solve, and we have a good interactive audience today also. It's a fun. I am final year M.Tech student. I'm final year M.Tech master student, by the way. Do you guys have anything to discuss, or I can end the string then? Just call me Viren, that's fine. Oh, that's first year. Okay, that's cool. Okay, okay, nice, Gaurav. Nice to see you guys in my next stream. Do join the stream. We have a interesting problem solution. Oh, you're from Gorakhpur. Meerut, Gorakhpur. Okay, okay. Interesting, guys. We have audience from all the corners of the India. We'll go international, guys, one day. So that's all, guys, for today. Thank you for joining. Have a good day. Bye bye. See you on my next stream.